Oxygen is a -2, okay? And sodium is a +1, so I've got to bring the 2 over there. All right, so now I've done step 1, step 2, and step 3. Step 4, look for special elements. Don't have any, okay? Don't have to worry about that part of it. Now I need to balance. What should I start with?
Lithium.
Yeah, probably lithium or sodium. They're both a 3. They both have +1 charge, so it doesn't really matter which one I start with. On the product side, I have 3 lithium. But on the reactant side, I only have 2. What's the lowest multiple that can balance? 6. Okay, so I'm going to put a 3 here to give me 6, and a 2 here to give me 6. This 2 applies to both the lithium and the phosphate. So that gives me 2 phosphates. So I've got to go back over to the reactant side and make sure that I have 2 phosphates. Putting that 2 there multiplies my 3 sodium. So now I have 6 sodiums. I have to go over to the product side and make sure I have 6 sodiums. Putting a 3 there gives me 3 oxygens. I go back and it looks like I have 3 oxygens here already, so now I'm good. The equation is balanced. Okay, questions on the first 2? Okay, keep going. I'll do another 2 here in a few minutes. All right, so on number 3, okay, we have phosphorus, which is an element, reacting with calcium nitride, which is an ionic compound. So what kind of reaction are we looking at? Single replacement. Okay, so we have a single replacement reaction. In a single replacement reaction, the lone element will replace the part of the ionic compound it is similar to. Since phosphorus is a non-metal, it is going to replace nitrogen, which is the non-metal. That means that nitrogen is going to wind up alone, and calcium is going to end up with phosphorus. Okay? Single replacement reactions require us to do both of step 3 and step 4. So step 3 is we have to drop and swap any produced ionic compounds. Phosphorus is a -3, calcium is a +2, so we got Ca3P2 as the correct formula for calcium phosphide. Do I have any special elements? Nitrogen is special. Okay. Now that I've got that, now I can balance. What should I balance first? Biggest number is phosphorus, 4. Okay, so I got 4 phosphorus on the reactant side. Now I have 4 phosphorus on the product side. Putting this 2 here now gives me 6 calcium. So I've got to go back over here and make sure that I have 6 calcium by putting a 2 there. That 2 gives me 4 nitrogens. So I need to go to the products and make sure I have 4 nitrogens in the products. And now that equation is balanced. Okay. All right, for number 4. I've got chlorine, an element, reacting with potassium, an element. What kind of reaction is that? It's a synthesis reaction. They're going to go together and make what kind of compound? Ionic. Potassium is a metal. And thus, when I write the formula, potassium needs to come first. Okay, metal first, non-metal second, right? This produced an ionic compound, so I need to check my drop and swap. Potassium's +1, chlorine's -1, so this compound is correct the way it's written. Now I need to balance the reaction. 2 chlorine in the reactants, that gives me 2 chlorines in the products, but that gives me 2 potassium, so I've got to go back over to the reactant and get 2 potassium there. How many people have done number 5? I'll look at that one too. All right. Only reaction type that starts with a single reactant is simple decomposition. And in a simple decomposition, the atoms are separated. So that means sulfur and oxygen as elements are my products. Okay? In all decomp reactions, we can skip step 3 because there aren't any ionic compounds produced, but there are lone elements. Are either of these going to require numbers? Both. Sulfur's an 8, oxygen's a 2. Okay, then I've got to balance this, starting with sulfur, biggest number. All right, I've got 8 here. I've only got 2 on this side, so 4 times 2 is 8. Now my sulfurs are balanced. But that gives me now 12 oxygens. So I've got to go over here and make sure that I've got 12 oxygens. Everybody all right with that? All right, I'll give you a few more minutes to get ahead of me again. For number 6, I've got copper, and it's reacting with lithium chloride. So I have an element reacting with an ionic compound. What kind of reaction are we looking at? Single replacement. Okay, so in a single replacement reaction, the pattern is the element replaces the part that it's like. That's going to be lithium that gets replaced. So I'm going to end up with Cu with Cl and lithium by itself. But here I run into a problem. Copper is an element on the reactant side and has no charge. It's in an ionic compound on the product side, and it has more than one possible charge. I have no way to figure out what that charge is in this reaction, so what do? I use the most common one, which is the first one listed, which for copper is 2+. Okay, and so we got CuCl2 on that one. Okay, and then I check for special elements. Lithium's not special. Okay, so it's done. Now I just need to balance it. There's 2 chlorine on the product side, which means I need to put a 2 here to balance the chlorine, and that gives me 2 lithium. So I've got to go back over here and balance my lithium. Okay, questions on that one? Okay, so that's one of those ones that's got a little exception in it. Okay, for number 7, I have potassium permanganate, and it's reacting with iron 2 sulfide. Is it important for me to know what the charge on iron is? It is, because iron's multivalent, and it's going to be in an ionic compound on the other side. All right, sulfur's a -2. That means iron must be the +2 variety in this reaction. All right, this is a double replacement reaction, so I'm going to swap the metals. That means that iron will end up with permanganate, and potassium will end up with sulfur. So I've produced 2 ionic compounds that both need to be dropped and swapped. I figured out that iron has a 2+ charge in this reaction. Permanganate is a -1, which means what needs to go around the permanganate? Brackets. Okay, and a 2 will go outside the brackets. For potassium sulfide, sulfide is a -2, potassium's a +1, so we're looking at K2S as our formula there. Now I can look at balancing the whole reaction. Okay, I'm going to start with potassium because it's first. Okay, there's 2 in the products, and now there's 2 in the reactants. That 2 also applies to the permanganate, and there are 2 permanganates on the product side. 1 sulfur, 1 sulfur, 1 iron, 1 iron. It's balanced. Questions on number 7? How many people have done 8? Okay, so let's have a look at that one too. Okay, so in number 8, I have 2 elements, hydrogen and nitrogen, reacting with each other. This is what kind of reaction? It's a synthesis reaction. All right, in a synthesis reaction, I'm going to make a compound out of these 2 things. Okay, metal, non-metal. So I'm making an ionic compound here, which needs to be dropped and swapped. Okay, hydrogen's a +1, nitrogen's a -3, so the 3 will go here, and now I've built my compound. I should balance whatever's in the highest number. Okay, that's hydrogen. There's 3 on this side, and there's 2 on this side. What do I need to use to balance? 6. Okay, so I'm going to put a 2 here, which conveniently balances my nitrogens, okay, and a 3 here to balance my hydrogen. How many people have done number 9? What kind of reaction is number 9? It's a combustion reaction. Okay, what are always the products of a combustion reaction? Right. Okay, so there's my product, CO2 and water. Do I need to use the rule of 2 on this one? No, 5's an odd number. All right, so I've got 5 carbons. Now there's 5 carbons in the products. I have 12 hydrogens, and now I have 12 hydrogens in the products. Now I need to look at how many oxygens I have. Right, so there's 5 times 2 oxygens for a total of 10 here, plus 6 more is 16. So there's 16 in total. What needs to go in front of this? An 8. Okay, questions on number 9? All right, last one. I have only one reactant. What reaction type is that? Decomp. Okay, in a decomposition reaction, the pattern is split them apart. All right, so I've got H and P. Are either of them special? Both. So H2 and P4. All right, what should I balance first? The phosphorus, yeah. Okay, so there's 4 on that side, and now there are 4 on the reactant side. That 4 also applies to the hydrogen for a total of 12. A 6 here will give me 12, and now the whole thing is balanced. Okay, How are we feeling about these? Starting to get the hang of it, and it's basically the same rules, right? I've walked through every single one of them, I've walked through those rules, okay, each and every time. It's probably getting annoying. I'm not gonna apologize, okay? It's gonna be annoying because you wanna make sure you don't forget any steps. All right, then I want you guys working on, okay, the rest of these ones here. If you get done up to 20, right, there's a few more down below, right? There's lots of practice questions in here. These ones are full reactions that you don't have to predict the products, but if you go down below that, from 17 to 24, you do have to predict those if you want to try a few that are written in word form instead. Okay, and that would be a good thing to try. Okay, so let's work on these. I think we stopped at like number 3 or 4 yesterday or something like that. So no, we did them all up then, and we did number 7 for sure. Okay, so let's say for sure get from 10 to 20 done today. Okay, and if you get further than that, great. If you got questions, come up and ask. Okay, I want to help you out, so come up and ask.